Why, hello there, everybody. Today we are talking about our introduction to simplifying radicals. And we did a quick little Desmos activity in class. And you guys noticed a pattern emerging. And one of your classmates noticed that if you were to take this outside number of 5 and times it by itself 5 and multiply by the number on the inside of the radical, which is 2, you end up getting 25 times 2, which is 50. Does that work for everything? So taking a look at the other two blue circled items here from our activity, if we took that outside number of 8 and times it by itself 8, and then multiplied by 2 from the inside of the radical, we got 64 times 2, which is 128. It works. Oh my goodness. So if we took 4 times 4 times 3, that ends up giving us 48, like in that bottom right question. So what I want you guys to do is write this down in your notebooks. Make sure you title this number 19, the intro. And these are your examples, okay? So you want to make sure you write down these 4 examples for me. So this first example is the following are equivalent radicals, and I want you to write down those 3 specifically because I'm hoping that you're noticing a little bit of a pattern emerging there. So using that same pattern we found in our activity, we would take 3 times 3 and then multiply these by the numbers under the radical. So 9 times 3 is 27, 9 times 6 is 54, and 9 times 7 is 63. So what would be equivalent to this form of 3 radical of 11 is our first question. Explain how you know. So we could take that outside number, 3 times 3, and then multiply it by the number on the inside, 11, which means that the 3 will come outside and the 11 will stay inside. And that is what we have there. Or we can just think of this as the square root of 99, ladies and gentlemen, is equivalent. All right, example number 2 coming your way. Please write down the following equivalent radicals, those 3, and we're going to talk those out yet again. So notice how all of those had a 5 on the outside of the radical symbol, which meant that we could take 5 times 5 and then multiply by the number under the radical, which was 3, 6, and 7. So 25 times 3 is 75, 25 times 6 is 150, and 25 times 7 is 175. So what would be equivalent to the square root of 275 then? So 5 times 5 times 11 makes 275. So we could write this as the equivalent expression 5 square root of 11. All right, time for example 3. So a student says that 5 square root of 10 is equal to the square root of 250. Without using your calculator, describe how you could show that they are, in fact, correct. So if we took that outside number of 5 times 5 and we multiply that by 10, do we end up making the square root of 250? And the answer is absolutely. So that's why these two expressions are equivalent. 5 square root of 10 is equal to the square root of 250. Last example. So number 4 here, and our final. A student wants to rewrite the equivalent form for the square root of 360. What could be one of those possible equivalent forms is what we're looking for. 3 of your classmates came up with some options. A second classmate said that we could use 2 on the outside, square root of 90, because 2 times 2 times 90 is 360. And third and finally, we could also use 3 square root of 40, because 9 times 40 is 360, or 3 times 3 times 40. So go ahead and practice today, guys, on number 20, and we'll come back together on Monday.